morning, guys. Today we will be working on Module 5, Lesson 17. Our objective is to draw parallelograms to clarify their attributes and define parallelograms based on those attributes. So just like we did in the previous lesson, we are drawing today. And here is our sheet. So our shape is a parallelogram, which is also a quadrilateral. And it's important you remember that the word quadrilateral means a shape with 4 sides. So at the top we have parallelogram. At the bottom, before we can draw the shape, we have to define it so we know what we're making. Okay, I'm throwing stuff on the floor. Hold on. So a parallelogram is a quadrilateral and remember, quadrilateral is a 4-sided shape with 2 sets of opposite parallel lines and opposite equal angles. It's also important that we realize that they have opposite sides that are equal. Okay, so I'm going to zoom out so you can see my workspace here. A little bit more. So here is where I am drawing, right between my title and the properties. The first thing we need to do is start with a straight edge. A paper is a straight edge. A ruler is a straight edge. So even if you don't have a ruler at home, you can use a piece of paper. And I am going to draw just one line. Hopefully you can see that all right. I don't know if that made it better or worse. And then I'm going to use my very sophisticated set square. Remember, a piece of paper can be a set square too because it has 2 sets of opposite parallel lines. And I am going to line my set square up on the line I drew. And I'm going to trace the top. So it now has given me 1 set of opposite parallel lines. And I'm just going to go ahead and lengthen that top line. The next thing I'm going to do is lay my rule, we're going to use our set square. I'm going to lay my set square between those 2 lines because I need another set of parallel lines. And if you look, I did not line it up equally. I am not making a square. I just kind of flopped it on there. And I'm going to line my ruler up with that set square. And I can finish drawing a line all the way through. I need to do the same thing on the other end of my set square. And I can draw my line through. So I know that these lines are parallel because I used my set square. And I know that these lines are parallel because I used my set square. By the way, parallel means they don't ever touch each other. So roads, the lines on roads, they should be parallel because you don't want to run your cars into each other. Sidewalks, both sides of the sidewalk, anything that is square or rectangular in shape, it should have at least 1 side of parallel lines, 1 set. So the next thing we are going to do is put our points because we are going to need to measure angles again today. And I am going to name my points. This is going to be A, B, C, and D. The next step is to measure our angles, and we are going to need to use our protractor for that. And if I start here at A, I'm going to flip my paper upside down. And And remember, we put the point in the hole on our protractor, and we line the line here up with the line on our protractor. So we line them up, and we follow from 0 all the way to where this line crosses. So we're going from 0, here's 90 degrees, so it's more than a right angle, it's more than 90. Here's 100, here's 110, and my line falls right in the middle of those. So it is equal to 105 degrees. I'm going to draw my little half curve there on A, and it is 105 degrees. And the label for this angle is DAB. Off to the side, just like we did in lesson 16, we're going to write angle DAB equals 105 degrees. And it's important to remember quadrilaterals that the sum of all their angles is equal to 360 degrees. If we don't get 360 degrees, we measured incorrectly. So now I'm going to flip it over and measure for angle B, which we will call ABC. Again, we put the point in the hole on our protractor, line it up. We go from 0 all the way up. It looks like I'm a little off there. There we go. 0 all the way up. Here's 70, here's 80. So it's less than a 90-degree angle, so it is not a right angle. When it's less, it's called acute. And I'm going to say this one measures about 75 degrees. So I'm saying angle ABC equals 75 degrees. And I'm going to label that here. Then I'm going to turn my paper, and we are going to do angle B, you can't see, BCD. Line our protractor up, same process. This is going to be an obtuse angle, which means it's greater than 90. We go from 0, we count around until we cross this line, and it meets between 100 and 110. So the measurement of this angle is 105 degrees. Hopefully, you just looked at that and realized our opposite angle is equal. That was part of our properties down in the bottom. 2 sets of opposite parallel lines and opposite equal angles. So this is 105, this is 105. Now that we know that they are equal, we should already be able to tell what this one is equal to. We're going to measure it anyway, but we should know it's equal to 75 degrees. We are going to write our angle down. This is BCD, and it's equal to 105 degrees. And our last angle here is going to be CDA, angle CDA. And we're going to measure it, but we should know that it's equal to 75 degrees. So I'm lining up my protractor. And if we count from 0, which is on the outside this time, here's 0. Our line crosses right here at just about 75 degrees. So we're calling it 75 degrees. And it is opposite of B, and they are equal. A is opposite of C, and they are equal. So angle CDA measures 75 degrees. And if we add these up, 5, 10, 15, 20, there's our 2. 7 and 7 is 14, plus 2 is 16. 1, 1, and 1 is 3. So our quadrilateral is equal to 360 degrees. So we know we measured our angles correctly. The last thing we need to do, because our properties say that opposite sides are equal, we're going to go ahead and measure those opposite sides. So I'm going to use my ruler. and I'm going to measure line segment, and this is how we write line segment, AB. So here is line segment AB. It is where the points A and B are connected. I'm going to line my ruler up, and it looks like this line segment is equal to 3 1/4 inches. So on top of it, I'm going to write 3 1/4 inches. Here I'm going to write line segment AB is equal to 3 1/4 inches. Now we should know that line segment DC is equal to it because it is opposite. Line segment DC equals, we're going to measure just to check, and we can see that it is also 3 1/4 inches. And we're going to label it. And to show that these two are equal, I'm going to put one line through the top and one line through the bottom, signifying that those line segments are equal. Next, we're going to look at line segment DA. That is where points D and A are connected. And so I'm going to call it DA. And we'll take our ruler and measure to the nearest 1/4 of an inch. And it looks like, again, this one is equal to 3 1/4 inches. And this one is going to be equal to 3 1/4 inches as well, because they are opposite line segments and they should be equal. So to show that DA is equal to CB, I'm going to put 2 lines through those sides. And that is how we create a parallelogram. Don't forget to do your exit ticket. If you do not have a ruler at home, a piece of paper works as a straight edge just fine. And the corner of your paper, just like this, works as a set square.